All right, we've got another problem here. In Khan Academy, this is an interactive problem. And the one thing I gotta remind everybody at the beginning here, and they say this in fine print, is this anchor point that they start with in green at the origin will always represent a midpoint value, even though you can move it to the left or the right, you can move it up, you can move it down. It's always going to be tied to wherever the midline should be. Okay, and similarly, this maximum point can either be a minimum or a maximum. You can move it down or up. You can even drag it left or right, but it will be pinned to one of those local extrema. So keep that in mind as you're going about this. And I say that because we see a cosine in this problem, and cosines do not go through the midline on the y-axis. So almost immediately, I just kind of scooch this point over and then drag this one over to where cosine usually starts. And then I have a little less trouble kind of getting my eyeball to see where this thing goes. All right, the other thing I have a little bit of a gripe about is how textbooks as well as Khan Academy write this without any layers on the inside. You've seen me in class and all the problems I've worked out with phase shift, keep it separate as an inner layer with B factored out in front of it. That way you could see literally what the phase shift is doing in that inner layer. So in order to figure out C here, we have a little formula. We're going to take the F value, which we can see right in the coding of this problem as positive 4 pi, and we're going to multiply that by 1 over the B value, or the reciprocal of B. Okay, and that goes pretty smoothly, and this will give us our C value, which we'll be able to figure out our phase shift then. So F is positive 4 pi, and we're going to multiply that by the B value's reciprocal. In this case, B is pi, so 1 over pi, and that will turn into 4 pi over pi, which you know will reduce to just 4. So our C value turns out to be just positive 4. I'm going to rewrite the whole model now. This is f of x. I kind of color code this with the blue 3. Cosine. And our B value is easy to spot. It's always that coefficient on the variable on the inside of the trig function. And then this is x plus 4 when you factor that B value out. And lastly, there is a vertical shift or a midline at positive 2. Okay, so I'm going to start by placing the midline at negative 2. Now, I recommend doing this on paper before you put your final answer in to Khan Academy so you don't botch it up by accident. So I'll just be scratching right over the top of this graph. So you see a green line I'm going to place right here at a height of 2. That's my midline, just to give my eyeball kind of a home for this curve. And next, we will kind of mark off the highs and lows of this thing. An amplitude of 3 means it'll never get higher than 5. Get that pinned down just right. Or lower than, what would it be, negative 1. Okay. So those are the so-called fence lines, 3 above, 3 below the midline. Now we got to talk about anchor points. Okay. Typically, cosine, which is what we're dealing with here today, starts at the top of its amplitude right on the y-axis. Okay, that's typically where cosine starts. What we have inside here, and I'm going to focus on this first, is the phase shift of 4 to the left. So I'm going to say phase shift 4 left. Okay. So that means I'm going to take that pink point I just placed on the y-axis and draw it over here. And I'm going to make that purple, okay? So that point was phase shifted left 4. Remember, when we add on the inside layer, we shift left. When we subtract, we shift right. Okay, so just to recap, this green dot right here that represents a maximum, since we're dealing with cosine, I'm going to drag it up here because that's the top of the amplitude, phase shifted left 4 with a midline at 2. Now, what we have to do is figure out where that midline point goes. And the idea there is that it's, yes, it's somewhere up here on this green midline, but where is it? Okay, so the spacing of this, the how far to the left and right is that second green dot, comes down to the b value. So we have a b value of pi, which tells us that the period, which we know as 2 pi divided by b, we could find the period using that b value to be 2 pi, plug in that b value of pi, and we get 2 pi over pi is just 2. In other words, one full cycle of this graph takes 2 units. Okay, that's pretty quick. What we need to do is find what 1/4 cycle or 1/4 period distance is. So to get from 1 to 1/4, we have to divide by or scale down by 4. So I'm going to scale 2 down by 4, and that is simply a half. A half is 1/4 of 2. The reason I'm talking about a quarter period here is because these 2 green dots start out exactly a quarter period apart. From a midline to a maximum is exactly a quarter period apart on sine and cosine. So let me erase that red mess I put there. Oops, got rid of the, there we go. And now we're going to move this last green dot that I was alluding to at the origin that represents midline to be exactly 1/2 away from the max. And I mean, when I say away from, I mean to the right. And if you're wondering why to the right, well, think about cosine. Cosine's curve, as you recall, starts at the top of its amplitude, has nowhere to go but down. Okay, so we already know that point. That's this purple point here. Now we're trying to place this point right here. So when I say away from, a half a unit away from to the right from the max. So we're at -4 for that first purple dot. We're going to go to -3.5 for that second dot. And that's pretty quick, only half a unit away. So I'm going to use some gray dots to kind of show where the rest of the curve will land up. Every half unit you get another anchor point. Now, that is such a tiny period that this looks like a V, but if you put a cosine curve to it, try to carefully sketch that, you'll see a shrunken period or a horizontally shrunk compressed graph. All right, so in recapping, you need your maximum point shifted 4 to the left at a height of 5 there, so that's at -4, 5, and you need the midline point, and maybe I'll put the coordinates for that one, -3.5, 2, right on the midline, and this other one was at -4, 5. That's where you place those 2 dots to get this model exactly where you want it.